Hello, and welcome Geometry A students. I'm going to go over in this lesson the Geometry A Unit 1 activity. So if that's what you're here for, then you're in the right spot. If that's not what you're here for, then check out one of the other lessons. Okay, this is my first ever video, so excuse me if there are some mistakes. I may re-record this later. We'll see. I'm just kind of doing it on the fly. Okay, so I want you to go ahead and open up the activity, the Unit 1 activity. So let me open that up myself. I probably should have done this earlier. Again, there may be mistakes here, so just bear with me. This will give you some time to open up the activity as well. Okay, so let me share my screen with you, and that way you can see what I see. Okay, so what we're looking at here is the very first geometry activity. Let's just get straight to it. I'm going to skip the introduction, skip this. Let's just go on to straight into working on the questions. Okay, so this one has to do with translations, rotations, reflections. Basically, those are what we call isometries, meaning that when you move a shape according to isometry, it doesn't change its shape or size. It may change its position, however. So the first one, it says write functions for each of the following transformations using function notation. Choose a different letter to represent each function. Okay, so for our translation, we're going to go ahead and use capital T. And if you use the equation editor, that's what I would suggest. So it's going to be T, and we're going to use a subscript, X, comma, Y, equals. So basically what this means is that this function takes on X and Y values. So that means there's going to be X values and Y values for this function. Now the first one, if you read the problem here, it says translate A units to the right and B units up. So what that function is going to look like is pretty simple. The X value will be increased by A. This will move the function A units to the right. You might be able to guess what the next part of this is, Y plus. That's it. That's it for the first one. Simple. So what this will do is it takes the function and it moves the function A units to the right and B units up. Okay. The next one we're going to talk about is reflection. So for reflection, I want to show you what that's going to look like. And this will make a lot of sense in a minute. So here I am, I'm on GeoGebra here. I just made this triangle earlier, triangle ABC. And so what we want to do is, according to this problem, we want to reflect it across the y-axis. So I'm going to go ahead, and on GeoGebra, you could see there's reflection tool here. So I'm going to reflect this triangle across the y-axis. So let's take a look at what happened to the points. Point A went from 2, 0 to -2, 0. Point B went from 7, 2 to -7, 2. And C went from 4, 3 to -4, 3. So as you can see, it reflected across the y-axis there. each point is the same distance from the y-axis. See that? So let's talk about this a little bit farther. So point A went from 2, 0, and then after it gets reflected across the y-axis, it ends up being A prime, which ended up being -2, 0. Point B went from 7, 2 to -7, 2. Sorry if my writing is not the best. I'm having to do this with a mouse. And C went from, wrong one. C went from 4, 3 to -4, 3. So take a look at what basically happened to the points. Well, the x-coordinate was the only thing that changed, right? So when you reflect across the y-axis, it goes from a point like xy point, an xy point. Notice the x-coordinate changes to negative, but the y-coordinate, nothing happens. So when you reflect across the y-axis, the x-coordinate becomes negative, and the y-coordinate stays as it is. Okay? So that's what we're going to put for this first one here. So for reflection, we're going to use capital R. So what happened to the x-coordinate? Well, it changed signs. It went to negative, right? It went from positive to negative, and if it was negative, it would go to positive, while the y stayed the same. Cool. Maybe I should change this a little bit. I'm going to change it just a little bit. I want to show that it's a reflection across the y-axis. Reflection across the y-axis, x and y. What happens to the x? It changes signs. What happens to the y? Nothing. So x will change signs, y will do nothing when you reflect across the y-axis, just like that. Okay, cool. Now we're going to talk about, the next one says reflect across the x-axis. So what does that look like? Well, let's go ahead and reflect across the x-axis and see what happens. So I have the same triangle, ABC, and I want to reflect, so I'm going to use the reflection tool in GeoGebra. Reflect this across the x-axis. Okay, so I want you to look at that. Notice that point A to A prime didn't change, but from point B to B prime, it went from 7, 2 to 7, -2. Point C went from 4, 3 to 4, -3. So notice the x-coordinate didn't change, but the y-coordinate did. Okay, so see if you can, on your own, write a rule just like we did for reflection across the y-axis. See if you can write one for the reflection across the x-axis. I'll let you do this on your own. Of course, if you need help, you're welcome to contact me. I want you to try to do this on your own, this little part, okay? So it's very similar to what we did for the y-axis. See if you can write a rule for the reflection across the x-axis. Okay, so you'll have to finish this up. Okay, next one. Rotation 90 degrees counterclockwise around the origin, point 0. Okay, so let's back up a second. Now I want to rotate my triangle 90 degrees. So I'm going to go to the rotate tool. I want to rotate this triangle around this point. I guess they want me to add a point here, so I'll add a point. Okay, so I'm going to rotate my triangle around this point. And according to the problem, I want to do it counterclockwise 90 degrees. So, okay, let's take a look at our points. A went from 2, 0 to 0, 2. All right. I'm going to change these numbers. Get rid of this. So A went from 2, 0 to 0, 2. Point B went from 7, 2 to negative 2, 7. Okay, so 7, 2 to negative 2, 7. Okay. And then point C went from 4, 3 to negative 3, 4. Okay, so let's take a look at the pattern. In this case, a point like xy rotating 90 degrees. Notice what happened. Let's look at point B. Notice the x and y coordinate kind of switched spots, right? See, notice the 7 was here. It was an x coordinate, but now it's a y coordinate. And the y coordinate became an x coordinate. Also, the x coordinate, or this 2 here, became negative. So when you have x, y here, they flip positions, right? You can see they flip positions here as well. So x, y will become y, x. And also, this one becomes negative when it switches. So that becomes negative. So this is for a rotation of 90 degrees. It goes from a point like xy to negative y, x. I hope that at least sort of makes sense. Okay, cool. So what are we going to write here? So for rotation, we usually use like a lowercase r for rotation. So I'm going to go ahead and use a lowercase r. And in this case, we're going 90 degrees. Is there a degree symbol? Yeah, there we go. Rotate 90 degrees. X comma y equals, so again, it becomes negative y comma x. Okay, cool. Next, we want to rotate 180 degrees. So let's go ahead and do that. So I'm going to take my triangle, just like before, and we're going to use the rotation tool, just like before. Rotate this around this point, and in this case, 180 degrees counterclockwise. Okay, so that's where that ends up. So notice for point A, it went from 2, 0 to negative 2, 0. For point B, it went from 7, 2 to negative 7, negative 2. So let's start looking at this. So A went from 2, 0 to 0, negative 2, 0. Forgive my mistakes. Negative 2, 0. Point B went from 7, 2 to negative 7, negative 2. Negative 7, negative 2. And we could already kind of guess that C went from 4, 3 to -4, -3. So you could probably see what's happening here. Both of the signs of these numbers change once it rotates 180 degrees. So xy, an xy point becomes -x, -y. Just like that. So let's go ahead and write that here. So for our next one, when we rotate, again using a lowercase r for rotate, when we rotate 180 degrees, y becomes -x, -y. Great. One more. Rotation of 270 degrees, counterclockwise. So let's go back a second. Rotate tool. Where is it? Rotate around a point, rotate this, around this. In this case, we want to do 270 degrees counterclockwise. So it ends up here. So it looks like point A goes from 2, 0 to 0, -2. Point B goes from 7, 2 to -7, 2 to 2, -7. And C goes from 4, 3 to -4, 3. Okay, so I want you to try to figure out, just like we did with the other ones, try to figure out what the pattern would be from here to here. Okay, I'll give you guys a couple minutes to try to, you could pause the video and try to figure that out, okay? And if you need help, you could always, if you can't figure it out, feel free to contact me anytime. Okay, so I'm going to give you the chance to do that one on your own. Okay. Now for the next one, how do these functions differ from other functions that we use in algebra? Well, one of the main things is that these functions will take 2 inputs and give you back 2 outputs. Most of the functions that you did in algebra, you did 1 input, usually an x, and you get an output, a y. So you put in 1 input, you get 1 output. But these functions that we just did, notice they take in 2 inputs, x and y input, and they have an x and y output as well. So 2 inputs and 2 outputs. Okay. Also, the results, the outputs represent points on the coordinate plane. You have to forgive me if I spell things wrong. I do that a lot. Spelling is not my strength. Okay, part C. So in part C, it says, in the same way the other functions can be combined, a series of transformations can be combined into a single function. For example, this statement for the function s shows one way to represent the rotation of a point 270 degrees counterclockwise about the origin, followed by a translation 3 units left and 1 up. Okay, so let's do one of these together. It says, rotate 90 degrees counterclockwise, and then reflect across the x-axis. So how would that look? So let's look at what we had before. So we want to rotate 90 degrees, and then we want to reflect across the x-axis. So rotation of 90 degrees is like this one. So we flip the x and y, and the y becomes negative. And we want to reflect across the x-axis. I think that's what it said, yes. So reflecting across the x-axis, hopefully you figured out here that this would be x comma negative y. So in our case, we want to rotate 90 degrees. So we flip the x and y, and the y becomes negative. And then we want to reflect across the x-axis, so this one will become negative. Okay. So for this first one, it'll look like this. That's too big. Okay. So for this one, it'll be, well, it's going to be a rotation and a reflection. So it'll be a rotation 90 degrees. Why did we do that? 90 degrees. And then we're going to use this symbol. Let's see, they have the symbol I want. We'll just use this symbol for now. And then a reflection across the x-axis. So you recall from up here, that would be negative y, negative x, and then this will become negative because of that reflection. So it'll become negative y, negative x. I know that's pretty tricky, but that's kind of how it goes. Okay. What's the next one? Reflect across the y-axis and then translate a units to the right and b units up. So first we're going to do a reflection across the y-axis. So reflection across the y-axis is negative x, y. So we're going to do a reflection axis. And then we're going to translate let's not put anything there. Translate a units up and b units to the right. Or a units to the right, b units up. Is that what it was? A units to the right, b units up. Okay. So what is that? So again, reflection across the x-axis. When you reflect across the x-axis, that's flipping it vertically. So the y-coordinate will change to negative. But we're going to also translate a units to the right. The y becomes negative because we're reflecting across the x-axis. And b units up. Okay. I kind of messed up on this first one here. I should have put an XY just like I did this one. Oh well. Next one, translate A units to the right, B units up, rotate 180 degrees counterclockwise around the origin, then reflect across the y-axis. So there's a lot going on here. So first, so it's going to be a translation. And then it's going to be a rotation, 180 degrees. So rotation. Give me a hard time. 180 degrees. And then it's going to be a reflection across the y-axis. So reflection across y-axis. X comma y. Let's see what happens. So first, we're going to translate A units up, B units to the right. So that would look like X plus A, Y plus B. Okay, then we rotate 180 degrees. So the rotation 180 degrees, well, let's go back up. The rotation 180 degrees changes them both their signs to the opposite sign. So this will become negative X, and also the A becomes negative 2. Negative, everything changes signs. Then reflect across the y-axis. So that's this way, flipping across the y-axis. So when you flip across the y-axis, the x coordinates change signs. So let's go back to being positive. There you go. That one's a tricky one. And that's that for that one. So for this one, we have a bunch of things. We have some soccer fields, some buildings, some baseball fields. All right, bunch of baseball fields. Okay. And we have to put these things onto this space. But we need to follow some rules. It says all the fields and buildings fit in the provided lot. So all the buildings and fields fit here. Each field is adjacent to at least one building for ease of access. 2 or more fields can be adjacent, but no 2 fields should share the same boundary. Okay, so they can't be like right up against each other. For safety reasons, no baseball field should have an outfield, the curved edge, pointed at the side, the straight edge of another baseball field. So you can't have like a baseball field like this, and then like, and then like another one like this. So this would not be safe, because if the batter hit a home run, it might go into this field, and that would be bad. Okay, so how are we going to arrange these things? And everything, all the fields need to be next to a building. That's kind of a key one too. So what I would suggest is maybe put all the soccer fields together here. Yeah, put all the soccer fields. And we could put a building kind of in the middle of them. I might need to move that a little bit so they're not touching the building. That way they're all close to the building, but not like touching the border of it. Now for the baseball diamonds, kind of want to put them all where they're all kind of pointing like towards each other. So one would go right here. And then one would go here. Similarly, all these need to be next to a building, so I'll put a building in the middle. Like that. Okay. And then do the other baseball diamonds in the same way with the building in the middle. Okay, so go ahead and finish. You can finish that up on your own. All right, well, that was the very first lesson of Geometry A, first activity, I should say. But again, if you need any help, like if this, you didn't get to answer all the questions, it didn't really make sense, you want a deeper explanation, please contact me, okay? My email address is trig@ofy.org. That's TTRIGG@ofy.org. Okay? Well, this is the first lesson. Bye. Good luck.